So in this example, you have an ultraviolet source of radiation that causes the emission of electrons from a zinc plate. You're asked to investigate what would be the effect of a more intense source. That's an important information. So we're going to increase the intensity, okay, on the same wavelength, so lambda doesn't change, on the maximum energy per electron as well as the number of electrons emitted per second. So what's the maximum energy per electron? We know that is your maximum kinetic energy of the electrons liberated. We are also interested in the number of electrons emitted per unit time. Okay, so how shall we go about doing it? Let's look at what we have. Now let's look at KEmax first. Now KEmax we know must be equals to HF minus phi. In this experiment, we're not going to change the zinc plate, so the work function is going to be a constant. Furthermore, when we look at the energy of the photon, because lambda remains constant, we also know that F is going to remain constant. Why? Because of course we know that F is equals to C over lambda, and therefore HF remains constant. What it would imply is that the maximum kinetic energy of the electrons will also stay constant, and that will help us eliminate some of the options. So let's look at some of the options. Obviously we see that A is wrong, D is wrong, and E is wrong. That leaves us between B and C. So what information have we not used? Yes, we have not used the very fact that intensity of the source actually increases. Now what happens when intensity increases? When intensity increases, the energy of each photon stays the same. But what happens to the number of photons that's supplied per unit time is that the number supplied actually increases. So since the number of photons increases, and we would expect, for example, then the number of electrons liberated should be proportional to the number of photons supplied. So we can give an example. Suppose that one electron is liberated for every 1,000 photons that are impinging on it. If we have now 2,000 photons, then we would expect that that would liberate 2 electrons. So when we increase the intensity, we will also increase the number of electrons that are liberated. So number of electrons that are liberated should logically increase. So we will have more, and more. So the number of electrons liberated per unit time should be more, and so C must be the answer. So the answer is C.